Hi, I'm an old guy and I do maths. Today we're looking at a simple binomial expansion, and we're going to do this expansion using binomial theorem with a little help from Pascal. Now, this is not a particularly difficult expansion, and it's entirely possible that one could do this longhand. Simply take these factors and multiply them out. But the idea of a binomial expansion is that it saves time, and I guess the problem really arises when this is not to the fourth power but maybe the 14th power, and you're tasked with expanding it. So let's have a look at what we're dealing with to start with. Here I've got a few things set out. Now, the general formula for a binomial expansion you see here, and this is featured in previous videos, so this is really just another look at it, and maybe looking at how swift and efficient this can be. Okay, so there are essentially two ways of dealing with this. One of the things that we have to find is we have to find the coefficients of each expression that we wind up with, and these can be found using this formulation, which you might know from probability as n choose k, and n, of course, is the index in the expansion, and k starts at 0. Now, how does this work? Well, here is the expanded form of n choose k, n factorial over k factorial times n minus k factorial. That can be a bit of a handful, especially if you don't have a calculator and you just can't ask it to formulate that. So what you can do, and what I tend to do, is use Pascal's triangle to generate the coefficient that sits in here. Now, this is very simple. If my explanation is a little fast, please excuse that. There is a video in the playlist about Pascal's triangle, and I'll link to it in the comments. Okay, so Pascal's triangle. What this allows you to do is to set out the list of coefficients for each power of an expansion. Now, the thing to note is that this is to the power of 1 here, to the power of 2 here, to the power of 3 here, and to the power of 4 here. So we have x plus y to the power of 4. These will be our basic coefficients of that expansion. 1, 4, 6, 4, 1, and that's what you saw set out on this page here. So let's go to work. Okay, so what do we do? Well, we have a coefficient, which is 1, and the first thing we do is we take our x value and we raise it to the power of n, which in our case is 4, minus 0. So that is 1 times x to the power of 4. And y, so I'll just make that x and that y so that you can see what I'm talking about. Y we raise to the power of k, and the initial value of k, which was 0. Okay, so that gives us basically x to the power of 4. That is 1x to the power of 4 times 1. 3 to the power of 0 is 1. Our next value is going to be 4 times x to the power of 4 minus 1, because k is now 1 as we move across the expansion, times 3 to the power of 1, k. Now, what does that give us? Well, 3 to the power of 1 is 3. 4 3s are 12. We'll deal with that. x to the power of 3. 4 minus 1. Next one. The basic coefficient is 6. We have x to the power of 4 minus 2, 3 to the power of 2. You can see how this pattern is working its way out. And just to remind you what's going on, x to the power of n minus k, that's 4 minus 1, 4 minus 2, 4 minus 3, and as this value here increases, this value, decreases, this value increases. Okay, 3 to the power of 2 is 9. 9 sixes are 54. X to the power of 2. I hope that's nice and clear. Okay, next thing. X to the power of 4 minus 3, so that's x to the power of 1, times 3 to the power of 3, which is 27. Okay, 4 27s are 7 4s are 28, that's 108. X to the power of 1. And we get down here to our last expansion, and we have x to the power of 4 minus 4, which is x to the power of 0, which is 1, times 3 to the power of 4. 3 to the power of 4 is 9 times 9, which is 81. And this is each one of the expressions in our binomial expansion. It is x to the power of 4 plus 12x cubed plus 54x squared plus 108x to the power of 1 plus 81. And if you wanted to include x in there, it would be x to the power of 0. What does this look like when it's finally properly expanded? Well, here it is. X squared plus 12x cubed plus 54x squared plus 108x plus 81. Now, I hope that you found this useful. As I say, if Pascal's a little bit of a mystery, there's going to be a link in the comments to a video on that, and to other binomial expansions that are in the playlist. Anyway, thanks very much for watching. Look forward to seeing you next time. Bye.